Good evening, everyone. We are in the week 9 problem solving session of the NPTEL course Network Analysis, and week 9 is about circuit analysis with dependent voltage sources or dependent current sources. Let me share my screen. Are you able to see my screen?
Yes, sir.
Okay. Okay, so in today week, before we go into the circuit analysis with dependent sources, first we'll be summarizing. I'll summarize what we have discussed in the last week. And also, last week we have discussed about how to get those three matrices, mainly A, B, Q, for a given network. But we have not discussed about how to solve a given circuit or given network using this graph theory. So last week we have only learned the terminology and how to formulate the equations, whether it is A matrix or B matrix, Q matrix. We have learned how to formulate the equations, but we have not discussed how to use those equations to solve a given network. So first I'll summarize this, then we'll move into how to solve a given network using this graph theory. Then we'll move on to the circuit analysis with the dependent sources, which is very easy, straightforward. Only we have to understand how they work, what are dependent sources. And yeah, so today in the first part, we'll be discussing the graph theory, which will be completed in 40-45 minutes. Then we'll move on to the dependent sources. So in the last week, which is week 8, we have discussed about graph theory. So first we have understood the definition of network, graph, directed graph, and simplified directed graph. And we have proceeded with the simplified directed graph for the rest of the discussion. So here it is a network, and the skeleton of that network is graph. If we mention all the voltages and current voltage polarity and current directions, then it is a directed graph. Instead, if we directly show the current direction and rename all the nodes, then it's just a simplified directed graph. Here we are not mentioning the current names or neither the current names nor the voltage polarity. Instead, we are giving the numbers to those branches. Then we have discussed about tree and co-tree. So tree is just a connection between the nodes so that no loop is formed and no node is left. And the branch of this tree is called a twig. Whereas co-tree is the rest of the branches which are not part of these trees. So that will give us the co-tree, and the branch of this co-tree is called link. So if in any given network number of elements are E and the number of nodes are N, then twigs will be N minus 1 and links will be E plus 1 minus N. And number of links is, or number of elements is the summation of number of twigs and number of links. I am audible, right? Hello?
Yes, sir.
Okay. So after learning this terminology, we have first moved into nodal analysis, then mesh analysis, followed by cut set theory. So in the nodal analysis, we'll apply KCL at each node. So if the current is leaving the node, then we have considered positive. If it is entering the node, we have considered negative. So we have considered three equations only, because one equation is redundant, as it is a linear dependent equation of these three, which are linearly independent. So we have considered only these three. And then we have formulated in terms of a matrix, A matrix. And then we have went into representing the element voltages in terms of node voltages. So we have considered the node voltages VA, VB, VC, and VO we have considered 0. Then we have obtained the element voltages VE1, VE2, VE3, VE4. Then we have written in another matrix equation, which will give this expression. And kindly note that I have written here mesh analysis. It should be nodal analysis. So I have corrected this and I have uploaded the same. So this two parts is for nodal analysis, but I have made a mistake and I have written mesh analysis. So I have modified here and uploaded the same. But in the video, it will be mesh analysis. So kindly note that. I have also mentioned in the description of that video that I have made this mistake. So kindly note this. So we got these two equations. Then we went to the mesh analysis, which is also called as loop analysis. So for doing loop analysis, first we have to identify the fundamental loops. So fundamental loops are those loops in which if we add any link, it will form a loop. And that loop is called fundamental loop. And number of fundamental loops are equal to number of links. So here we have three links. So we got three such fundamental loops and we have applied KVL in those loops. and we have to apply KVL in such a way such that the coefficients of the link will be 1, not -1. So we have considered, we have understood what should be the direction in which we have to traverse in that loop, so that we'll get the positive expression or positive coefficient for that V4, V5, V6 or the links. Then we have realized that B matrix will have identity matrix inside it, and this by this method, by applying KVL, we'll be getting the B matrix. Now we are getting the other equation of the B matrix, which is the B transpose matrix. And in this part, we'll be representing the element currents in terms of the loop currents. So the loop current will decide the direction of the current, and then we have represented the element currents in terms of loop currents. And here also we'll be getting another identity matrix, and this gives us the other equation. So one equation we got from the this loop analysis, fundamental loop, we got B into V is equals to 0, and from here we got B transpose into IL is equals to I. Then we moved into the cut set method. So cut set method, we have discussed what is a cut set. Cut set is anything, any line that cuts a given network into two halves, so that each of them half will have at least one node. If it cuts only one twig, which is a branch of a tree, then it is called fundamental cut set. So we have to consider fundamental cut set for this, which are equal to number of twigs. And if the current direction in a branch is same as twig, then it is positive, else it is negative. And you can consider either the left side or the right side, but you have to consider the left side uh, for all the branches. You cannot consider left portion of this cut set for this branch and this branch. So accordingly, you have to consider. So either you consider left portion of all the cut sets or right portion of all the cut sets, or individually also consider left portion or right portion for all the branches that are part of that cut set. And after applying KCL, we got a unity matrix here. Uh, sorry, we got identity matrix here, and this will give one equation. And for the other equation, you have to write the element voltages in terms of twig voltages. So twig voltages are like V1, V2, V3, VT1, VT2, VT3, and the rest of the voltages we have to write in terms of these voltages, which will give us another expression or another equation. So using cut set method, we got again two equations. So summary, again here I have made a mistake. I have copy pasted, so it got as mesh analysis, but it is nodal analysis. So the summary of graph theory are like using nodal analysis, we got two equations in terms of A matrix. Using loop analysis or mesh analysis, we got two equation in terms of B matrix. Using cut set method, we got two equation in terms of Q matrix, and A matrix is also called as reduced incidence matrix. B matrix is also called as fundamental tie set matrix. Q matrix is also called as fundamental cut set matrix. And later we have solved a few problems. But after this, today we'll be discussing the relation between these A, B, Q matrices, and then we'll see how to solve a given network using this graph theory. So till now, do you have any doubts till this point? So if you have any doubts, we can discuss, else we can move on to today's session. Do you have any doubts?
No, sir.
Okay. So today's session is week 9, right? So week 9. First, let me copy paste the slides that I need. Okay. So today, first part, we will be discussing about graph theory only. Then we'll move to the dependent sources. So first part, I'll be discussing about the relation between the matrices. Okay, yeah. So we'll be using whatever we have discussed in the last week, and we'll be formulating based on that. Why it is causing issue? Okay. Okay. So let me correct this also. So this is mesh analysis, nodal analysis. So we got this equation: A into IE is equals to 0 and A transpose into Vn is equals to Ve. And also, if you go back to our previous equation, we know that A matrix consists of two parts. One is the twigs and other is the links. Because if you see, the number of rows are equal to twigs, right? So that is fine. And if you see the number of columns, they are equal to E. So E means what? E means number of elements. And we know number of elements is equals to number of twigs plus number of links, right? So A matrix, similar to these matrices, it has two parts. First part is corresponding to twigs. Second part is corresponding to links. So A matrix, I can write as two subparts. Mainly the first subpart is twigs and the second subpart is links. So is this clear how I'm writing? So it has similar to this. First part is twigs, second part is links. Here the second part is having another additional property which is identity matrix, but here there is no such property. So A matrix I am writing as A twigs and A links. Is this clear, or are you having any doubt?
Cleared, sir.
Okay. So now if I do A transpose, if you see in the A, left side is twigs, right side is links. Whereas in the case of A transpose, top side is twigs and the bottom side is links. You follow? This is 100. If you see these nine blocks, 100, 0 minus 1 1, 0 0 minus 1, 100, 0 1 minus 1 1, 0 0 minus 1. So if you consider this horizontal, in the case of A transpose, it will be vertical. So if I write A transpose, I can write like there will be a tall matrix, the top part being A twigs transpose and the bottom part is A links transpose. This line, whatever this line I'm mentioning here, it is not division, it is just separating those two. So it is not a division, just take a note. It is just the separation between twigs and links. So I can write this, right? So A matrix can be written something like this. Do you agree until this point? Hello.
Sir, repeat it once again, sir.
Okay. So if I consider A matrix, the number of columns are equal to number of elements, and I know number of elements is nothing but number of links plus number of twigs. So this E can be written or broke down into twigs plus links. So similar to what we have done for the B matrix, which we have divided into B twigs and B links. Here B links is nothing but identity matrix. So we have written U links. So similarly, first I have broken down this A matrix into two parts. So what we have done is, so we have drawn a line here, and this part corresponding to A twigs, and this part is corresponding to A links. So which is what I have written here. A is corresponding to A twigs and A links. Now if I do the transpose, A transpose, again here also the top part will be twigs and the bottom parts will be links. But now the top part is not 8 weeks. It is instead of 8 weeks, it is 8 weeks transpose because we are doing transpose. Because here, if you see the second row is 0 minus 1 1, it is the column 0 minus 1 1. So it is like the top part is related to twigs but transpose. So 8 twigs transpose, and the bottom part is related to links, and it is a links transpose. So I have written A transpose in this format. So it has one matrix on the top and one matrix on the bottom. So I'm segregating the twigs and links. So accordingly, we can multiply. So we are just dividing A matrix into two parts, or A twigs into A links. So A matrix is like this and this. We are this is just a separation. So it has two matrices inside. I am considering this 3 cross 3 as one matrix and this 3 cross 3 as another matrix. So my A matrix is nothing but 8 weeks, which is 3 cross 3, and here it is 3 cross 3. So total it is 3 cross 6. So is that clear?
Yes, sir.
So similarly, we can write B matrix also the same thing. We can write B matrix is equals to B twigs and B links. But B links is having an additional property, which is that it is an identity matrix. So identity matrix we are representing with uh, UL. So B is having B transpose, B twigs and UL. UL is what? UL is mat identity matrix. Okay. So similarly, if I do B transpose, then I'll be getting something like this. It will be also this in the same way. Top part will be BT transpose and bottom part will be UL transpose, and UL transpose and UL both are same, so it is just UL. Because if I do the transpose of identity matrix, it is still the identity matrix. So UL transpose is equals to UL. Similarly, for cut set method, we have identity matrix at the beginning. So for the twigs, it is identity matrix. For the links, it is non-identity matrix, you can say. So if I do the same thing for this part also, let me write Q. So here we have Q is equals to U twigs and then Q links. If I do the Q transpose, we will be getting U twigs and Q links. And similarly here, U twigs transpose is equals to U twigs. So we have just written these matrices in a different way, so that whatever we'll be doing next, it will be easy for us to do all the mathematical analysis. So we have just written these matrices in a just a different way. So until this point, is this clear? What we have done, we have just written the matrices in a different way. So is this clear?
Yes, sir.
Okay. Now these matrices are related. We have to find the relation between these matrices, but also there is some orthogonality between these matrices. So A and B are orthogonal, and B and Q are orthogonal. So by this I mean, So here we'll be getting one equation. Here we'll be getting another equation. So it is like A into B transpose is equals to 0. And here B into Q transpose is equals to 0. So now using this equation, we'll find the relation between A and B. Here also using this relation, we'll find using this equation, we'll be finding the relation between B and Q. So using this new representation of the matrices and these equations, we'll get the relation between AB, BQ as well as AQ. So first part is relating A matrix and B matrix. So relating A matrix and B matrix. Okay, so first I'll be considering this equation that we have over here, which is A into B transpose is equals to 0. Okay, so I'll put it here. And then for A matrix, I'll consider this. So again, I'll copy paste it here. Okay. Then for B transpose, I'll be considering this matrix. So we have it over here. So now I'll substitute this A and B transpose in this equation, and it will give me A twigs and A links into B twigs transpose and U links. So in a matrix multiplication, we know that uh, we'll do the row of the first matrix with the column of the second matrix. So here we have written it in a row format and this in a column format. So what will be multiplied? So these two parts will be multiplied. So twigs and twigs, and then links and links. If you see, the row of this will be multiplied with the column. So twigs will be multiplied with the twigs and links will be multiplied with the links. As if you want to say, I have a matrix. Let me use a different color. As if I have a matrix here 1, 2, and I have a matrix here 3, 4, which will be 1 into 3 plus 2 into 4, right? So this is the red part, like 1 into 3 is the red part, and this is 2 into 4, 2 into 4. So here instead of 1 and 2, we have another matrix, but our representation is just similar. So 1 will be multiplied by 3, 2 will be multiplied by 4. Similarly here, twigs and twigs, links and links. So if I do that, I will be getting something like this. A twigs into B twigs transpose plus A links into U links. So identity matrix into any matrix is that matrix itself. So A links is equals to 0. So now we'll have A twigs into B twigs transpose is equals to minus into A links. So until this point, is it clear how we are multiplying it and getting this equation?
Yes.
Okay. Others also? I hope it is clear. Okay. So now we'll multiply by 8 twigs inverse on both the sides so that we'll be left with only B matrix on the left hand side. So we will have B twigs transpose is equals to minus A twigs inverse into A links. So this is the relation between B as well as A. So if A matrix is given, then I can get B matrix. How? First I'll get B twigs and the other part is just U links, right? Which is an identity matrix. So if A matrix is given, I can get the B matrix easily. Only I have to do this mathematical manipulation. So here we have considered this orthogonality relation A into B transpose equals to 0. And we have written the A matrix with our new representation and B transpose matrix with our new representation. And then we have just done the mathematical or matrix multiplication. And then we have multiplied with the A twigs inverse on LHS and RHS, and it is done. So similar to A and B, now I can do for B and Q. So relating B and Q. The same thing, same method we'll be using. So relating B and Q. So again, I need B matrix and I need Q transpose matrix, right? So I'll copy paste it and I'll just directly substitute it. So this is B into Q transpose. So first I need to get B matrix. So this is our B matrix and Q matrix, Q transpose. So this is our, sorry, this is our Q transpose matrix. I'll just substitute and do the same multiplication I have done in the previous case. So if I do this, we will be getting B twigs and U links multiplied by U twigs and Q links is equals to 0. Same thing we'll do twigs multiplied by twigs and links multiplied by links. So just the, if you consider the same example, it is just like a row matrix, sorry, a row matrix multiplied by a column matrix. So we are multiplying in the same format. So I'll just put over here. So we are using the same logic. So if I do that, we'll get B twigs into U twigs. Identity matrix into any matrix is just the matrix itself. So we'll have B twigs plus Q links is equals to 0. So if I do that, I want Q in terms of B, right? So I'll be getting Q twigs, sorry, Q links is equals to Q links is equals to minus B twigs, or B twigs is equals to minus Q links. Sorry, this is transpose. I have made one mistake here. So this is Q links transpose. So this is Q links transpose. Because we are doing Q transpose, it should be Q links transpose. So the same mistake has been carried over here. So this is also Q links transpose. And this is also Q links transpose. So this is also QL transpose. So QL transpose is equals to minus BT, or QL is minus BT transpose and BT is minus QL transpose. So this was the mistake. If you are doing Q transpose, so it will be UT transpose and this will be QL transpose. So that mistake, it got carried over here as we have copy pasted. So we got a relation between Q and B. So we got relation between A and B, and again we got relation between Q and B. So now how to get the relation between A and Q? I will be using these two to get the relation between the other two. So let me draw a, take a new sheet. So now we are relating between A and Q. Relating A and Q. So we'll take the two results. So one result is this, whatever we have obtained in the first case, copy paste. So this is our first result and this is our second result. Okay. So now I know that BT transpose is nothing but minus QL. So if you substitute this in this equation, we will be getting minus Q links is equals to minus A twigs inverse into A links. So that implies Q links is equals to minus AT inverse into A links. This will be plus. So this is the relation between Q and A. So this is our first equation. So this is our first relation. And this is our second relation. And this is our third relation. So if one matrix is found, like A matrix is found, you need not repeat and find the other matrices. You can use this relation instead and get the other matrices by doing some inversions and matrix multiplication, and this will directly give us the other matrix. So until this point, is this clear?
Yes.
Okay. If you have
Yes,
any
sir.
doubts, you can ask. Else, now we'll go to how to solve a given network using this network analysis. Oh, sorry, graph theory. So our next topic is solving a given network using graph theory. So if I go back to our last week discussion, if I go back to week 8, in the week 8, you have seen that we have considered any element. Say, let me go back to our first example where we have discussed this. Yes. So here, any given element, I have written as this box, right? Say, fourth element is some box. I have represented it as a box. So if we consider, what we have done is, we are considering a box type of representation for kth element. Say the names nodes are A, B, and say this is our kth element. We said that it has a current I element K, so I E K, and the voltage V E K, right? We have said this, right? The current is I E K and the voltage is V E K. Do you remember? Hello.
Yes, sir.
Yeah. So now what we will be doing is, we'll consider a generalized kth element. What could be the possible case of a kth element? It could be voltage source, it could be any impedance, or it could be having a current source, right? So we'll consider a general representation of that. So it is valid for any case, because kth element could be a resistor connected in capacitor connected in series with a voltage source of 2 volt, or it could be an inductor connected in parallel with a current source. So that representation we are not doing here, but now we'll consider a general representation. So this one we are considering within the same thing. We'll be considering one voltage source and one impedance, as well as one current source. So this is our A, this is our B, and this is the current I E K. Okay, and this is the voltage plus minus VEK. So now we have considered one current and voltage, and this is our ZEK. So impedance can be anything. ZEK means it could be RLC, it could be RC in parallel with L. So it is just an impedance. So it could be, it is in the format of A plus IB. To be precise, it is plus A plus J into B. So it can be anything. And it could be having some voltage source as well, right? So the voltage source is, say, VSK, source voltage in kth element, VSK, and this is ISK. So the current here will be IEK plus ISK. Do you agree? So if I consider a dotted format, this kth element, this block is equivalent to this block. So this kth element block could be anything. It could be just a voltage source or a current source or a combination of these two and having some impedance. So we have considered a generalized such example of that. So it is now a generalized equation. So is this clear until this point? Hello.
Yes, sir.
Okay.
Yes.
Okay. So now what we'll be doing is first we'll be using the B matrix. So there are three matrices we have. One is the A matrix, one is the B matrix, one is the Q matrix. So first part we'll be using the B matrix. Okay. So let us apply KVL here. VEK is nothing but VSK. Again, there is less than a minute. So if this meeting and kindly join back, then we'll continue with our discussion. So VEK is nothing but VSK plus ZEK into this current. Do you agree? So what I'm saying
Yes,
is
sir.
VEK is equals to VSK plus ZEK into IEK plus ISK. Do you agree?
Yes, sir.
So this is for a kth element. Now if I write for n such elements and I write in terms of a matrix representation, I will be getting VE matrix is equals to VS matrix plus ZE matrix into IE matrix plus ZE matrix into IS matrix. Is this clear? So we can write in this matrix formation. You agree, right?
Yes, sir.
Okay. Now let me just keep it in the right bottom side. Now what I will be doing is I will be multiplying with B matrix here as well as here. Or okay, so we'll be multiplying with the B matrix. Now I'll be writing the B into VE is equals to B into VS plus B into ZE into IE plus B into ZE into IS. So let us quickly go back to our first page. We know that B into VE is 0, right? And B transpose into IL is IE. So we need loop this thing. So B into V is 0, first of all. So this part I can write LHS as 0. So this part is 0. So this part is 0, 0 matrix. Now in the RHS, what is the unknown? Because in this case, what is given? VSK is given, ZEK is given, ISK is given. We have to find IEK, right? So here, what is the unknown in this entire expression?
I.
IE, right? So IE is our unknown. And if you see the equation over here, IE is what? B transpose into IL, right? So I will be substituting that. And also I'll be writing this equation so that in case you go through the notes, you will not face any difficulty. So these are there. So B into V is 0 and B transpose into IL is equals to IE. So in this IE, we can substitute this and keep that in the LHS side. So now what we will be getting, if I substitute that, I will get something like this. I will get B matrix into ZE matrix into B transpose matrix into I loop currents, fundamental loop currents is equals to minus B into Vs minus B into ZE into Is. Right. So this is our equation that we have obtained. So now in this equation, only IL is the unknown. So if we get the value of B into ZE into B transpose, and if we invert it and send into the RHS side, we will directly get the IL, which are the fundamental loop currents. So now once you get fundamental loop currents, you can directly get IE also, right? You will get IE. So this B transpose into IL is IE. So I'll get IE. So once I get IE, then I'll know IEK plus ISK, then we'll get VEK using this formula. So once you get IEK, ISK is given, ZEK is also given. So using this equation, you will get VE. So what are the unknowns? Unknowns are IE as well as VE. So from here, you will get IE, which if you substitute over here, you will get VE. So we'll apply KVL, the same thing. If you see in this part, if you go to the B matrix, so in the B matrix, what we did actually in the B matrix, we applied KVL, right? So here also we have done the same thing. We have applied KVL and multiplied by B matrix. Then we have simplified it. We got one equation from which you will get IL or IE, which you, if you back substitute here, then you will get V. So is this clear how to use B matrix and solve? So for any given such network, first we'll get the B matrix, and then we will multiply it by the B matrix to get in this form, and then we'll solve this matrix to get IE. Then using that, I will get VE. So is this point clear? How we are using B matrix?
Yes, sir.
Now we'll use A matrix. So for A matrix, obtaining A matrix, what did we do in the B gate? We have applied KCL. So using KCL, we will get one equation. Then we'll multiply multiply it by A matrix, similar to what we have done today. So let us copy paste this in our next page. So second part is A matrix. So this is our second part. A matrix. Okay. So now we will apply KVL. Sorry, we'll apply KCL. So I'll apply KCL at this node. So I'll write IEK plus ISK is equals to VEK minus VSK by ZEK. Meaning the current that is entering this current IEK plus ISK is nothing but this potential difference minus this potential difference by impedance. So we have calculated what is the potential difference across ZEK? VEK minus VSK divided by ZEK is the current flowing through it, which is IEK plus ISK. So did you understand how we got this expression? IEK plus ISK is nothing but, or you can also get it from here. IEK plus ISK is nothing but VEK minus VSK by ZEK. Only we are writing in a different format. Understood this equation?
Yes, sir.
Now, 1 by impedance is what? Admittance, right? So we'll write in terms of admittance. So IEK plus ISK is equals to YEK VEK minus YEK into VSK. So same thing I'll do. I'll first write in terms of matrix. So if I do it for the entire circuit, I'll get IE plus IS is equals to YE into VE minus YE into Vs. Now I'll multiply with A matrix on both sides. So we have A into IE plus A into Is is equals to A into YE into VE minus A multiplied by YE multiplied by Vs. So now we'll see what are the results that we have in the A matrix, under the A matrix. So we have these two equations. So A into IE is equals to 0 and A transpose into Vn is equals to VE. So I'll be using this. So A into IE is first of all 0, which means this value is 0. And VE, so in the rest of the equation, IS is given, YE is given, VS is given, A is also known. So only VE is the unknown. So you have to substitute VE over here and keep it in LHS and bring everything into the RHS side. So we will be having, if I write this, A matrix into YE matrix into A transpose into V node voltages is equals to A into YE into Vs plus A into Is. Do you agree? I have just put this VE here and then I have written the rest of the equation. Do you agree?
Yes, sir.
Yes, sir.
Or yeah, so we are using the same method and we are seeing whether we are getting in this similar format. So the basic idea is simple. For using A matrix, we need the equation in terms of IE. For using B matrix, we need the matrix or the equation in terms of VE. For cut set method, we need the equation in terms of IE. So we are using the mathematical manipulation to get in the similar format. So we are multiplying accordingly so that we can use these relationships and then we can get the resultant equation. Now, if you see what is the difference between A and Q, A and Q, we have here Q into IE is equals to 0 and Q transpose into VT is equals to VE. So here instead of V node voltages, we have V twig voltages and rest of the things are same. So what I mean to say is, yeah, first let me 3. Okay, so 3 is Q matrix, right? So here now we have the third part, which is the Q matrix. For Q matrix also we need in terms of QIE, then we will multiply by Q matrix. So the equation is simple. So let me just copy paste this. So if we consider the same thing, Control C, Control V, and keep it in the corner. So first we have to use the same equation. We have this equation. Now we have to multiply it with Q matrix on LHS as well as RHS. So we'll do the same thing. So we'll have Q into IE plus Q into IS is equals to Q into YE VE minus Q into YE into VS. Now we'll go to the Q matrix and use the results that we have obtained for the Q matrix, which are these two equations. So Q into IE is also 0 and Q transpose into VT is equals to VE. So first of all, this is 0 and next of all, we have to substitute VE here. Then what is the equation that we'll be getting? We'll be getting Q into YE into Q transpose into V tweak voltages is equals to Q into YE into V source voltages minus or plus Q into I source voltage. So we obtained this type of equation. So now from this we will get V tweak voltages. If you substitute it here, we will get VE voltage, then you will get IE voltage. Sorry, IE current. So basically, the main intention is for any kth element, we need to know IEK and we need to know VEK. So we need to know IE, we need to know VE. If you want to use B matrix, you have to write in terms of VE and multiply it by B so that you will get fundamental loop currents, using which you will get element currents, using which you will get element voltages. If you want to use A matrix, you have to write in terms of IE and multiply it by A so that first you will be getting the node voltages, using which you will get the element voltages, using which in this equation you will get the element currents. If you use Q matrix, it is exactly similar. First you will get twig voltages, using which you will get element voltages, using which you will get element currents. So is this clear until this point? How to use the matrices and uh, solve for the given network, solve for voltages and currents in a given network.
Yes, sir.
So let me consider one example. So in any given circuit, first you have to either proceed with A matrix or B matrix or Q matrix. So say first we are fixed and we are saying we'll go proceed with the B matrix. Then we have to get the B matrix first, then ZE matrix, then VS matrix, then IS matrix. Then you have to substitute everything here. Then you will get loop currents, using which you will get element currents and other currents as well. So let us quickly consider one example. So in the previous week 8, we have thoroughly understood how to get A matrix, how to get B matrix, how to get Q matrix. Now we have first discussed the relationship between these matrices and how to use this matrix to solve for a given network. So whatever we have learned in the last week is to obtain the matrix, which is very crucial. And if you solve more problems, you will be easily getting that matrix. So after getting that matrix, you just have to plug in correctly and you have to uh, find the corresponding voltages as well as currents. So we'll consider one problem. So this is our problem one. So we have considered a generic case while discussing theory as if each element has a voltage source, current source, and impedance. But in reality, it may not be because not every element will have all the things. Sometimes it may have only a single voltage source or probably current source or impedance or any combination of those three. So here we have one example, which is what I have considered what Sir has discussed in the lecture. So I am considering the same thing. So all of you are following, right? You are understanding, or am I going at a faster pace?
Understanding, sir.
If you feel that I'm going at a faster pace, you can tell. Then I'll slow down a bit. So this is 10 volt, and this is 12 volt. Okay. So first of all, we have to identify the nodes, and nodes are what? Any junction where three or more branches are connected. So how many nodes are there in this?
The two.
How many?
Two.
The two.
So I'll consider one to be reference node and the other one is node A. So I'll be considering the same thing, O and A. So this is my O and this is my A. Now I have to consider the branches or elements. How many elements are there in this given question?
Three elements.
Elements. So one is the mid and this one is the other one and this one is the other one. So I'll consider all the currents to be in the bottom direction. It could be anything. From the question, you know that current will flow like this, current will flow like this, current will flow like this from the given thing. But let us assume that we do not know the currents and we have assumed everything in the bottom direction, and we will see whether we are getting the correct result or not, because uh, every time we need not know the direction of the current. So here we are considering we do not know and everything is in the down direction, and we'll see. Now if this is the direction, what is the polarity? Say first let me consider this is element 1, this is element 2, and this is element 3. So this is our element 1, this is our element 2, this is our element 3. So according to this voltages, the current direction, what is the polarity of the element? Plus on the top or plus on the bottom?
Plus on the top.
Plus on the top. So in all the cases, plus is on the top, minus is on the bottom. Okay. So now I'll consider only one method. So we'll solve this problem using B matrix. So we will solve this problem using B matrix. You can solve it using Q as well as A, but I'll mention only B matrix. Similarly, you can solve for other things. Okay, so first, as we are solving using B matrix, the first part is we have to obtain the B matrix. So how to obtain the B matrix? So for obtaining the B matrix, we know that we'll apply KVL in the fundamental loops. For getting the fundamental loops, or maybe I'll just show so that you can also. So for obtaining the fundamental loops, first we need to calculate the tree. Then we'll find number of fundamental loops or number of links, and then we'll apply KVL and we'll directly get the B matrix. Okay. So here, how many elements are there and how many nodes are there? Number of elements. Can you tell me how many number of elements?
3.
3. And how many number of nodes?
2.
Sorry, 2. So number of twigs will be
1.
yes. So if we see here, number of twigs is n minus 1, right? So number of twigs is n minus 1, which is 1, and number of links
2.
2, which is e minus t. So we have 2. So there is only one twig. So in our tree, there is only one twig. So I'll consider 1 as a twig. So first let me copy paste this. So we'll use this same. So I'll put it here. Okay. So this is my tree. Okay. So this is our tree. Now how many fundamental loops are possible? Number of fundamental loops.
So 2.
2. Number of fundamental loops, because number of links are 2. So number of fundamental loops is equals to number of links. So one is because of L2 and the other one is because of L3. So we have, so let me consider again two such scenarios. One is here, the other one is here. Okay. So first loop is because of L2. So this is our loop. Let me use this. Let me use a blue color. So I'll consider this one. Fundamental loop. So I'll mention it as loop L2. So in loop L2, what we'll be doing, we'll apply KVL, right? And we have to be sure for that link, the voltage should be positive. So if we apply in this loop L2, can you tell me what is the expression? So we have KVL in loop L1. So KVL in loop L2, KVL in loop L3. So in loop L2, if we apply KVL, what is the equation? And in loop, we'll go to L3 first. Here we have element voltages 1 and 2, right? So can you tell me what is the expression for KVL in loop 2? In this loop.
Sir, VE2 minus VE1.
Yes, right. VE2 minus VE1 is equals to 0. So for others,
Zero.
why it cannot be VE1 minus VE2?
Sir, link voltage, we have to consider it positive.
Positive. Yes,
in that.
yes, you are right. So link voltage we have to consider positive. Here the link is 2, which is VE2. So in our equation, VE2 should be positive. That is our convention that we are following. Similarly, if I consider L3, so this is our L3. And this is our loop, right? So in this loop, if you apply KVL, what is the equation?
Sir, VE3 minus VE1
VE3 minus VE1 is equals to 0.
is equal.
So now we'll formulate the B matrix. So the B matrix has elements. So the rows are elements and columns are loops. So loop L2. So here we have loop L2. Here we have loop L3. So elements are 1, 2, 3. So in the first row, what we'll be getting? Coefficients.
-1 + 1 0.
-1 + 1 0. And second,
-1 0 + 1.
0 + 1. So this is multiplied by VE1, VE2, VE3, and RHS is 0. So how many links are there in this network? Number
2,
of
sir.
2.
Sir,
So
2.
if you see, our identity matrix is also having 2. And this is the BT. So this is our B twigs. And this is our U links. And totally is our B matrix. So just to write our B matrix, therefore B matrix is -1, 1, 0, -1, 0, 1. And similarly, if you write the B transpose, row will be column. So row is -1, 1, 0, -1, 1, 0. And here -1, 0, 1, -1, 0, 1. So this is our B transpose. So first we have obtained the B as well as B transpose. And using this, we'll solve the network. So first we'll go to the B matrix equation. Okay. So in this equation, first we will see what are the knowns and what are the unknowns. So this is our result that we have obtained previously, and this is our question. So you tell me, first of all, IS matrix, what will be the IS matrix? IS matrix. So IS is 0.
Source current
Yes,
0.
yes, 0. Because there is no source in any of the element. So IS is 0 and it will be a column matrix. So IS, first of all, IS matrix is 0, 0, 0. So the other term is not there. So this entire term becomes 0. Now we know B matrix, B transpose matrix. We have to calculate VS matrix and ZE matrix. Okay. So what will be our VS matrix? So VS is VS1, VS2, VS3. VS1 is of element 1, VS2 is of element 2, VS3 is of element 3.
0, 10, 12.
So element 1 is 0, 10, and 12. Right? Hello.
Yes,
Yes,
sir.
sir.
Yes. Okay. Now I have a question. Why it is not
Sir,
0, -10, -12, or how do
yes,
I know?
sir. Yes, sir.
Yes. Yeah. You tell me how will I know whether it is +10 or -10, +12, -12? Any ideas?
Sir, we have considered current direction earlier,
Yes. Yes. So we
taking
have
that it will be minus.
yes. Yes. You are right. So but it is not minus. That I'll come, but depending upon the current direction, it is coming. So first, I'll go back to our convention. So whatever logic you have said, it is completely correct. So in this question, if you see, our convention is A is positive, B is negative. So this is VEK, and the current is flowing from A to B, and VSK is also in this direction, plus and minus. So plus is on the same side of VEK, and minus is same as VEK. In this scenario, current is flowing from positive to negative. So now I'll come back here. If you consider this, plus is on the top, minus is on the bottom, and current is flowing from top to bottom. So if you consider the same thing, plus is on the top, minus is on the bottom. So plus here, minus here, plus here, minus here. So current is flowing in what direction? Current is flowing in this direction. Current is flowing in this direction. Current is flowing in this direction. So in such scenario, if our VSK is also having the same polarity, then our VS is positive, because our VEK is also positive, right? If you consider the B matrix equation, we have considered VEK is equals to VSK plus ZEK. So here it is just positive VS, right? Plus VS. We have not considered anything, right? Did you follow?
Yes, sir.
Yes. So based on our convention, it will change. So I think this color got changed. I'm just copy pasting it. Sorry. So based on our convention, it will change. So now you may ask, if I consider 1 in downward direction, 3 in top direction, and 2 in top direction, for 1, plus will be on the top, minus is on the ground. For 3, plus is on the bottom, minus is on the top. For 2, plus is on the bottom, minus is on the top. So in that case, if plus is on the bottom, this will be minus 12, this will be minus 10. So the convention is very important. So whatever convention that we have considered here, according to that, plus is on the top, minus is on the bottom, which is satisfying with this 12 volt as well as 10 volt. So we'll have element 1, we have 0, element 2 we have plus 10, and element 3 we have plus 1. Now you in during your free time, you can do one uh, small test. What you can do is, instead of considering the currents here, you change the currents first. If you change the currents, B matrix will change. So B matrix you calculate and consider the B matrix accordingly, because the voltage polarities will change if you change the current. B matrix change, B transpose changes. And similarly here also, plus 12, plus 10, these things will change. So this part also you have to be careful. So maybe today or tomorrow, whenever you are free, consider a different current directions and do the same procedure. Probably you will be ending up with a different matrix, but the answer should come same. So here it could be plus 10 minus 12, minus 10 plus 12, or minus 10 minus 12. But you do that. So you'll get confidence, because now we will be tending to feel that how uh, any polarity will give us the same answer. What if I change the polarity? Why it should give the same answer? It will give the same answer if you do everything according to your polarity. So my your convention. So my convention is currents are flowing down. So using this, if I do, then it should give a same answer, and it will always give the same answer. If you had not gotten, it means you have made a mistake, but it is never that it will not give a different answer. So if you follow the same convention without making any mistake, then you should end up getting the same answer. Okay. So now if you see ZE matrix, first of all, what is the size of B matrix?
2 by 3.
2 cross 3. And B transpose?
3 cross 2.
3 cross 2. So here B matrix is 2 cross 3, and this is 3 cross 2. So what should be the size of ZE? Anyone? What should be the size of ZE? So that the matrix multiplication will happen.
3
if
cross 1.
3 cross, so if it is 3 cross 1, this side, left hand side, it will be multiplied, but right hand side, it cannot be multiplied, right?
Yes, sir.
Yeah, so it should be what? 3 cross
3.
3 cross 3. So if it is 3 cross 3, then these two can be multiplied, these two can be multiplied, overall it will be 2 cross 2. And IL is what? 2 cross 1, right? So IL is 2 cross 1. So if I multiply all these things, I will be getting 2 cross 2. And then if I multiply 2 cross 2 with 2 cross 1, I will get 2 cross 1. Similarly, if you check on the other hand side, the RHS side, B is 2 cross 3, VS is 3 cross 1. And if I multiply these two, I'll get 2 cross 1. So the size of LHS, RHS should be same. So my ZE matrix is 3 cross 3. Instead of 3 cross 1, it is 3 cross 3. And it will be like this. So ZE, in the first row, it is 0.8, right? So it is 0.8, 0, 0, and 0, 2, 0, 0, 0, 4. So 0.8 is branch 1, 2 is this one, and 4 is the other one. Got it?
Yes, sir.
Yes. So now
Yes, sir.
we'll substitute everything in this. So B into ZE into B transpose. So first we need to calculate. Okay, so let me copy paste this also. So B into so our LHS is B into ZE into B transpose into IL, right? So B into ZE into B transpose. You can check if you have any calculator or anything. B into ZE into B transpose. What is this value? I'll just skip this calculation part and I'll directly go to the answer. So if I consider IL on LHS side, so what it will be? Just a minute. So if I consider IL directly, so my IL is equals to this B into Z into B transpose inverse, right? So minus of B into Z into B transpose whole inverse into B into Vs, right? Do you agree? Whole this part into B into Vs. Do you follow? I'm doing this
Yes,
part
sir.
is 0. So this part I'm inverting and it will come before this. So minus into this inverse into B into Vs. So this is our fundamental loop current. So solve for IL. I'm not showing the details because it is just a mathematical calculation. If you calculate, you will be getting ILS minus 3 minus 2 minus 3 minus 2. So you will get this. You can check the calculation. I'll get IL. But what do I need to know? I need to know IE, right? Element currents. I need to know element currents, right? I need to know I1, I2, I3, right? Isn't it?
Yes, sir.
Yes. So how will I calculate element currents using the loop currents? I'll use the other result, which is this one. B transpose into IL is equals to IE. So if you use that result, B transpose into IL is equals to IE. If you do, then you will get IE, element currents. Okay. If you do that, again, I will directly write the answer. IE is 5 minus 3 minus 2. 5 minus 3 minus 2. So you'll be getting this IE. So these are the currents that it is saying. My math is saying these are the currents. But let us quickly go back and see whether it is correct or wrong. So I1 is how much? 5, and the other I2 and I3. So my current, this current is 5. This current is -3, which also means that current to the top is 3, right? So this is 3 and this is 2, right? Do you agree?
Yes, sir.
So at this junction, here we have 2, here we have 3, bottom we have 5. First of all, KCL is not being violated, right?
Yes, sir.
Yes. So now I'll again quickly cross check. So VA is how much? VA is 5 into 0.8, right? There is less than a minute. If this meeting end, kindly join back. So VA is 5 into 0.8, which is 4 volts. Then I in 4 ohm is 12 minus 4 by 4, which is 2 amperes. Similarly, I in 2 ohms is nothing but 10 minus VA 4 by 2, which is 3 amperes. So it is perfectly matching and everything is correct. KVL is correct, KCL is correct, nothing is violated. So you have understood these steps, right? I am calculating
Yes, sir.
using these currents. I'm just verifying it. Okay, so let me summarize what we have discussed in this problem. We have considered a network. Here we have three branches, so three elements. First, we have identified the nodes. Then we have assumed the current direction according to which we have decided the polarity. We have first solved for the B matrix. After getting the B matrix, we have used this result to calculate the fundamental loop currents. So B into ZA into B transpose is there. So first we have to know IS. IS is 0 because there are no IS. Then we have got a VS, and the polarity of this VS comes from the polarity of VE, which you should use this. So you have to follow this, and accordingly you have to see what is the polarity and other aspects. So using that same polarity, we got Vs, then Zd we have also obtained. Then from this equation, we got IL. Using this B transpose into IL is equals to IE, we got the element currents. So after getting the element currents, you can also check and solve for individual voltages. So this is just the summary of application of the graph theory. Here we have considered usage of B matrix and how to solve it. Instead of B, if you use A matrix, first you have to obtain A matrix and use the uh, result of the A matrix and then proceed. Similarly, for Q matrix, you have to do. Probably the values will differ because here you are getting fundamental loop currents. In the case of A matrix, you will get node voltages. Node voltages. In the case of Q matrix, you will get twig voltages. So it will differ, but the end element currents and element voltages should be same. So now you got IE, right? Similarly, if you want VE, then you have to use this equation that V is equal to Vs plus Zd into IE plus Zd into Is. If you use this, then you will get element voltages as well. So that part you can do, and later you can try using this small simple example. You can try using different current directions and accordingly voltage polarities, and also you can consider A matrix and Q matrix so that you will get an overall understanding of how to use this and how to uh, get. So you may ask one very question like, why for this simple problem, why I have to do 2 pages of solution? Instead, I could directly apply KCL and KVL. I can simply solve in two equations, two unknowns, or three equations. Here you will get two equations, two unknowns. So what is the big deal? Yes, for this problem, maybe graph theory is not the simplest or less time consuming way. But instead of here, we have three branches. Instead of three, say if we have 13 or 15, 20 branches, then you will get 19 or 20 equations, right? So in order for you to draw each and individually and do KCL, KVL, it will be very much time consuming and it will also be complicated. So instead of that, if you get these matrices and directly plug into some computer. So here you have to plug in B matrix, ZA matrix, VS matrix, IS matrix. And using that, you have to do inversion and matrix multiplication, which will give this matrix. So you need not do anything. So, and this is a systematic way of getting the matrices, B matrix. What is the how to get the B matrix. So even for very big complicated network, you know how to get the B matrix, and you just have to write this ISVS and ZA matrix, and you just have to plug in to any mathematical toolbox or any computer. It will do the calculation and it will directly give. Instead, if you have to do mathematical like hand written, then you have to simplify each and every equation, and the complexity and the probability of making mistake will increase as the network increases, the complexity of the network increases. So graph theory will be very much useful as the complexity of the network increases. But for simple cases where it has 2 to 3 branches or 4 branches, it may not be the best solution or least time consuming solution. But still, one should know this so that if the complexity increases, then you need not draw all the equations and solve it by yourself. Instead, you can do a systematic way of getting the matrices, and you just have to use this result to obtain the element voltages and element currents. So as the complexity increases, you will see the advantage of graph theory. But here we have considered very rudimentary example because it will be easy for us to understand the concept. So the main point of this example is to understand the concept. So a very small simplified example is considered, but you can increase the network size, and then you will see the benefit of graph theory over conventional methods. So that being said, if you have any doubts in the graph theory, you may ask, else we'll go to the dependent sources. So do you have any doubts until this point? Okay, I'll consider that as a no. Now we will do circuit analysis with dependent sources. If you have any doubts, you can ask. Circuit analysis with dependent sources. So what are dependent sources? Dependent sources are like its magnitude, the whether it could be voltage or current is dependent on voltage and current in some other branch. So the magnitude of voltage or current of these sources depend on the magnitude of voltage and current of some other branches. So what is the, so this is just a very rudimentary definition, but we'll see how to solve such equation by considering few examples. So there are different examples, like you can say any transistor. Probably you might or might not have studied, but I'll just give a brief thorough understanding. And also, if you see two coupled coil or mutually coupled coils, you have seen that voltage is induced in one coil is function of current in the other coil. So it is dependent. So the voltage value of that in the coil one is dependent on the current in the coil two. So it is the same, right? The magnitude of the voltage of that particular element is dependent on the magnitude of the current in the other coil. So mutually coupled coils. Here I'll give one example of transistor. I'll consider BJT. If you are not taught about BJT, then it's okay. Just don't think about it. But if you know, then I'll just take one example. So I'm considering NPN. So this is the base. This is the base, and this is the collector. This is the emitter. And if this is the base current, in the case of BJT, the collector current is just a constant beta of any transistor. Beta is fixed for a transistor. So this collector current is a function of base current. So it is a constant multiplied by the base current. So this current in this branch is a dependent function of the current in this branch. So this IC is a dependent source on this current. So this is just one example. If you know BJT, then you'll be able to understand. Else, also it is fine. Uh, but it is a practical example. So if you have any doubt, like from where or what are the application of dependent sources, and the representation of the dependent voltage source and dependent current source, instead of circle, we'll use this kind of symbol. Say this is plus minus. Similarly for current, we'll use the same symbol with the current direction. So this is our dependent voltage source. And this is our dependent current source. So this is the representation. So you also have to follow this representation. That means it is a dependent voltage source. So if you draw circle, it is a independent voltage source. Similarly for current, if you use circle, then it is also independent current source. If you use this symbol, then it means it is a dependent voltage or dependent current source. So let us quickly take one example, or you can say another problem. So we are in problem 2, right? So this is problem 2. And then we will solve this problem 2, which has a dependent voltage or current source. So the problem is something like this. Oh, here one resistor, here one resistor, and here one dependent voltage source, here another resistor, and here a independent voltage source. And this is 4 ohm, this is 10 volt, and this is I1, and this is 6 ohm, and this is 2I1, and this is 2 ohm, and this is given as I2. So this is a problem where they have mentioned that there is one dependent voltage source and its magnitude is 2 into I1. First of all, I1 we don't know, and this voltage source also we don't know. So it is like if the current I1 is 1 ampere, then this voltage source is 2 volt. If the current is 0, then this is 0. So this is the basic understanding of the dependent voltage or current source. The basic idea is simple. It's not a straight fixed value. It is a dependent value, and you have to solve using that. So now if it is I1 and this is I2, what is the current in this?
I1 minus I2.
I1 minus I2. So now we'll apply KVL in this one. So can you tell me what will be the expression that we'll get? Plus 10. I'll start from here and I'll traverse through this network in this way. 10
Sir, minus 4 I1
Hmm.
minus
minus
I1 minus sir minus 6 I1 minus
6 into I1 minus I2 is equals
I
to. So if we solve that, we'll get 10 I1 minus 6 I2
6
is
I2 is
equals to.
equals to 10.
So if I divide by 2, it will be 5 I1 minus 3 I2 is equals to 5. This is one equation. I need another equation. So for another equation, we'll traverse in the outside loop. So what will be the equation? Plus 10 minus 4I1, right? Then
yes.
Minus 2I1 minus 2I2.
is equals to 0. So now
0.
we'll get 6I1 plus 2I2 is equals to 10, or 3I1 plus I2 is equals to 5. So this is our equation, two equations. two unknowns. Say this is equation 1 and this is equation 2. Now I will do equation 1 plus 3 times equation 2. Then I will be getting equation 1 plus 3, right? 5i1 plus 3 is 9i1, and 3i2 minus 3i2 will get cancelled, is equal to 5 plus 15. That implies I1 is 20 by 14 or 10 by 7. So 10 by 7 amperes. This is our I1. If you substitute this I1 in this equation, you will get I2 is 5 minus 3i1, 5 minus 30 by 7. So I2 is 5 by 7. Right? Did you understand? We are just getting two equations, applied KVL in the small one and KVL in the larger one. We got two equations. Using those two equations, we just found out I1 and I2. Did you get it?
Yes.
Okay.
Yes, sir.
So in this way, we'll solve for currents I1 and I2. But there is one issue with the dependent sources when it comes to Thevenin's theorem. So we'll discuss that one. So there is one issue we'll discuss. Thevenin's theorem for networks considering with or we can say network for any network with dependent sources. So what is the issue and how to proceed? We'll consider the same example. So uh, this is the example. Okay, so this is the example, and I'll remove this. Okay, so this is the example. So say we need to apply Thevenin's theorem, and we'll apply Thevenin's theorem for this 2 ohm. So for this we'll apply. So first part is I have to calculate Thevenin voltage, and the second part is I have to calculate Thevenin impedance, right? Isn't it?
Yes, sir.
So for Thevenin voltage, what is the process? How to calculate Thevenin voltage?
Open circuit the load and calculate.
Yes. Yes. So we'll remove that. So I'll just copy paste the same example. So we'll open circuit it. So this will be open circuited, and this will give us our VTH. This is plus, this is minus VTH. Okay. And let me also remove these currents. This is 2i1, and this will not be there. This will not be there. This will not. Okay. So first of all, what is the current in this path? 0, right?
Yes, sir.
So current is 0. So now what is this current? Say this is I1 current. What is I1?
1 amperes.
1
10 divided by 10.
10 divided by 10. Yeah, you're right. So I1 is 1 ampere. Okay. Now what is this voltage then? This voltage, what is the value of 2i1?
2 volts.
2 volts. Right. And what is my VTH?
4 volts.
Yes, which is 6 minus 2. So VTH is 4 volts. There is no issue. The issue is with the Thevenin impedance. So we know that what is the procedure for Thevenin impedance?
Short circuit the voltage sources and open circuit current sources.
Yes, short circuit this open voltage sources and open circuit the current sources. So those are the independent sources. So what will happen with the dependent sources? Because it cannot be short circuited, right? The only way
Yes, sir.
this becomes zero is when the current here becomes zero, but the current there is unknown. So what is the procedure? So how to proceed with this? So that is the issue with the Thevenin's theorem. So how to proceed with that? We'll discuss that. So what happened? So our circuit is here. So let me remove these marks again. Okay. So we have this circuit, how to find the ZTH. So first of all, we know that this will be short circuited, right? So this will be short circuited. First, the independent sources, but the dependent sources will not be short circuited. So this is short circuited. Now, how to find ZTH? Because we do not know this voltage and how to find the impedance. So then what is actually ZTH? ZTH is nothing but the impedance seen by these two terminals, right? So now what I will do is I will connect a voltage source, known voltage source. Okay. V input and say the current it supplies is I input. Now I know my ZTH is nothing but V input by I input. Do you agree? Yes or right? Yes or no?
Yes, sir.
Yes. So now I'll assume the current direction. This is my current direction. Again, there is one important thing. This 2I1 is I1 when I1 is flowing from left to right. So the polarity should not be messed up with. So you have to be very careful with I1. So I1 is flowing from left to right, then the polarity is this. If it is the other way, here also polarity will be reversed. So I have considered the same polarity I1 and this is IN. So this will be how much?
In plus I1.
I1 plus IN, yes. So now I have to uh, get a relation between V in and I in. So first of all, apply KVL in this region. So can you tell me the equation? We'll start from here and we'll go here. Hello.
Hello, sir.
Uh,
10 I1 plus in is equals to 0.
sorry.
10 I1
Okay, 10 I1. So I'll write like this. So others will also understand. 4 I1 plus 6 I1 plus 6 IN is equals to 0, right?
Yes, sir.
So now if I divide it by 2, we'll get 5 I1 plus 3 I in is equals to 0. Everything should be in V in or I in. So I1 is minus 3 by 5 I input, right?
Yes, sir.
Yes. Now we'll apply in this KVL. I'll start from this node and I'll come back here. So can you tell me the equation? It will be V in plus V in minus V in
Plus V in.
plus V in. V in then minus or plus 2I1
Plus 2 I1.
plus 2I1 then
Minus 6 I1 plus in.
minus 6I1 minus 6 IN is equals to 0, right?
Yes, sir.
Now we will get V in
I1
is equals to 6 in plus 4 I1, right? Right. isn't it?
Yes, sir.
Yes.
Yes, sir.
Now I'll substitute this I1 here. Then I'll get V in is equals to 6 into I in minus 12 by 5 I in, right?
Yes, sir.
So my V in is 18 by 5 I in, right? Isn't it?
Yes, sir.
Yes.
Yes, sir.
So what is my Z Thevenin then?
18 by 5.
18 by 5 ohms. So I got V Thevenin, I got I Thevenin. So now I can construct a circuit. This is my VTH. This is my VTH. And this is my ZTH. And this is the load. So what is the load here? The load is 2 ohms, right? 2 ohms. And my ZTH is 18 by 5. And where is the VTH? This is the VTH. VTH
4
is
volts.
4 volts. So now the current flowing through the 2 ohm, which is the I2. What is the expression for I2?
4 divided by 18 by 5 plus 2 ohms.
4 divided by 18 by 5 plus 2 ohms. So it is 4 by 18 plus 10 into 5, right? 20 by
Yes, sir.
28. So if you simplify, how much you will be getting? I2,
5 by 7.
5 by 7. So now we have applied Thevenin's theorem and we got I2 to be 5 by 7, which is same as what we have obtained by directly solving. But only catch is Thevenin's theorem for calculating the Thevenin impedance. You cannot directly calculate it. So you have to assume a source V and supplying a current IN where ZTH is V in by IN. So you need an equation in terms of V in and IN, which will give us ZTH. So dependent sources, there is no concept as such. Only you have to understand what is dependent source, what is dependent current source, voltage source and current source, and you just have to solve any given problem by carefully taking consideration into the polarity and direction. So here 2I1 means I1 is flowing in left to right direction, so I have assumed the same polarity so that there will not be any confusion. And then I got VTH, then we got ITH, and we have solved. So is that clear how we are getting that?
Yes, sir.
Okay. Others?
Yes, yes, sir.
Yeah.
Yes, sir.
Okay, okay. And Nia Farhan, do you have any doubts? Hello. No, sir. Okay. Okay, then we'll solve one previous year problem. So we are in week 9. So let me consider. As there is less time, we'll be getting only like very less time to solve. So which one will solve? You tell me which one to solve. First problem or second problem or third problem or fourth problem. So whichever we'll see if any question gets more votes, we'll proceed with that one. So this is 1, 4, this is 3, this is 2, this is 1.
4.
Okay, others? Fourth. Okay. Then we'll start fourth question only. It may be looking complicated, but okay. So we have fourth question over here, and today it is problem 3. So this is today's third problem. Okay, so what they have asked in the question. So you just read out the question, or you just read the question, so you will know what is asked in the question. And let me know when you have read the question.
So we have to calculate uh, electrical sorry,
Power,
electrical power supplied or generated by dependent and independent sources.
independent sources. So it is like this source, and this source. So we have to find out the power. So for calculating the power, we need to know voltage and current. So for current source, we need to find voltage. For voltage source, we need to find current. So first of all, they have made it complex. So they have mentioned currents and voltages in each of the branches, which is redundant, and it is making it look like complicated. So what I will do is I will redraw it because it is complicated and I don't want it to look that complicated. So we have one dependent current source over here, and this is my representation of writing the voltage source. So I'm writing in this, but you can use the circle as well. And here there is this dependent voltage source as well, plus minus, and here we have resistor. So for voltage source, we need to find current. For current source, we need to find voltage. So this is the current direction, and this is 6 volts, and this is 10 ohm, and this is 5 ohm, and this is 8 I2, and this is 8 V1. So they have given this. We are free to consider the ground. I'll consider the ground as this. Okay. So first of all, what is V1? What is V1?
6 volts.
6 volts. So we know that V1 is 6 volts. So then what is 8 V1?
48.
48 amperes, right?
48 amperes. Yes.
Yes. Okay. So here this is like 8 admittance. So it is like V1 by ohm. So to match the units, they have written it that way. There is no other intention. Here also voltage source means resistance into current, right? So that's why they have mentioned 8 ohm into I2. But we know that for current it is amperes, voltage it is volt. So yeah, it is fine. So can you tell me what is this voltage?
6 volts.
6 volts, right? And this current is 48 amperes, right? Right?
Yes, sir.
Yes, sir.
Can you tell me what is I2? Okay. 0.6, Mia Farhan has mentioned 0.6. Do you agree? 6 by 10, right? I2 is 0.6 amperes. Do you agree?
Yes, sir.
Okay. Now can
Yes,
you
sir.
tell me what
Yes,
is
sir.
I1?
48 plus 0.6.
Yes, 48 plus
48.6.
40.6. So I1 is 48.6 amperes. So now I know V1, now I know I1. So for this voltage source, 6 volt source, so they have asked independent source, right? By the independent source. So this is the independent source, other two are dependent. So they are asking power supplied or generated. So power supplied or generated. So I know that power supplied by this 6 volts is nothing but 6 volts into the current 48.6.
48.6.
So how much we will be getting? So I have done the calculation 291.6. Just check if you are also getting the same thing or not.
Yes, sir.
Okay. So 6 volts is 280, 291.6, and it is also within the region. Now we have to know the power supplied or generated by the dependent current source and independent or dependent voltage source. So now we need to find the voltage across this source. Okay. Now, what is I2? How much is I2?
0.6.
0.6. So what is 8I2?
4.8.
4.8. So what is the voltage of this node?
4.8 volts.
4.8 volts. So this is V3, right? Plus minus V3. So what is V3?
10 minus 4.8 volts.
Is it 10?
Sorry, 6 minus 4.8 volts.
Yes. So V3 is 6 minus 4.8, which is 1.2, right? V3 is 1.2 volt. Okay. Now power supplied by this dependent source. So power supplied by this source, say P supplied by 8V1 source. How much it will be? Voltage into current, right? Current is how much?
Yes, sir.
48 ampere. What is
48.
voltage?
48 into 1.2.
So whether it is plus 1.2 or minus 1.2. So is it acting like a current source or sink? Source, right? So Nia Farhan is saying source. Do you agree, or is it a sink? Okay. Let me ask you another question, then you will be able to say. So this is what and this is what. I have considered different polarity. One is wherever the arrow is pointing, I have considered positive. Wherever the arrow is considered, I have considered negative. So left one is source or sink, or right one is source or sink.
The right one is source.
Right one is source and left one.
Sir, right one is a sink, sir.
Okay.
Like resistors, capacitors, it will be.
And left
Left
one.
one is a source. Source.
Okay. So wherever the pointed end is there, if that is positive, then it is source. Else it is sink, right? The pointed end, like this end, current source end, wherever it is pointing, if it is positive, then it is source. If it is not, then it is sink. Do you agree? Yes. Okay. So now tell me whether it is source or sink.
Sink.
Sink. Yes. So in the question, they have asked power supplied or generated by the dependent source. So whether it is supplying or whether it is consuming power.
Consuming power.
Consuming. So it is sink, right? So it will be minus 1.2 because it is not supplying any power, it is taking power. So this will be our P8V1. So if you multiply 1.2 48, you will be getting 57.6 with minus. So did you understand? You have to be careful whether it is a source or sink and see whether it is a positive sign or it is a negative sign. Got it?
Yes, sir.
Okay. So we'll check whether it is matching. It is inside it, so it is matching. Now we'll go back to this question. And so what is my I5? Can you calculate and tell me what is I5?
1.2 divided by 5 ohms.
1.2 or
Divided by 5.
how are you getting 1.2?
Sorry, sir. Current
4,
I is equals to V by 4.8 divided by 5.
5. Yes, yes. So I5 is 4.8 divided by 5. So this is how much you are getting? It is 0.96, right? Okay. So now I5 is obtained. So what is the current in this direction? This is minus I4, right? I have considered the opposite direction. So how much is minus I4? Or how much is I4? If it is confusing, how much is I4?
48 minus I5.
Yes, 48 minus I5. 48 minus 0.96. So it is 47.04 amperes. Okay. So now tell. So it is 47.04. Now you tell me whether it is acting like a source or I mean whether it is consuming power or it is delivering power. This source 8I2 source
Consuming powers.
consuming power. So in the question they have asked how much it is supplying. So again it will be a negative sign. So if you consider that, so power is voltage into current, right? Voltage is how much? 4.8. So 4.8 into 47. So power consumed by the, what is that source? 8I2. Power consumed by 8I2 is equals to 4.8 into minus 47.04. So if you calculate, you will be getting power consumed by 8I2 is equals to how much? Minus 225 something you are getting. So minus 225.
Minus 225.79.
792. Yes. So this is the power that you will be getting. So this much power it is consuming, minus 225.792. So if you check the answer, it is also within this range. Now they are asking what is the power consumed or dissipated by the two resistors. So power consumed by the resistors means I square R, right? So how much is I2? 0.6 square into 10, and I5 is 0.96 square into 5. So power consumed by the resistor is I square summation of I square R, right? Summation of I square into R. So in one case it is 0.6 square into resistor is 10. Then in the other case 0.96 square into resistor is 5. So if you do that, you will be getting power
8.2.
how much?
8.208.
8.208 watt. Okay, thank you. So this is the power consumed by both the resistors. So if you get back here to the question 8.20, right? So it is also falling in the region. So just for a just to summarize, in the last problem we have considered the given circuit and they were asking the power supplied or uh, consumed by the sources. So we have to find the currents across voltage sources and sorry, current through the voltage source, flowing through the voltage source, and voltage across the current source. So we have calculated the currents and voltages from which we have seen whether they're consuming the power or whether they're delivering the power. And finally for the resistor also we have done the same thing. So do you have any doubts until this point, or if you have any queries regarding anything you can ask? No sir, all clear. Okay, thank you. If you have any questions you can ask, else I'll just quickly summarize what we have discussed today and then we can end this session. And how are you doing in your assignments, weekly assignments? Are you doing good, or are you facing any difficulty, or how is your
Yes,
experience?
sir. It's a good, sir.
Good. Okay. And are you liking this course?
Yes, sir.
And what about others?
Yes.
Okay. Okay. Someone has mentioned in the chat. Yes, here. it is to my liking and my field of interest. Yeah, good. Good that you are liking, and this is like it is everywhere. So solving a given network is like eternal. So even you go in different electrical domains, like in different application in electrical engineering domain, still networks and solving the circuits will be there. So it is always there. Okay, just to summarize, we have started with the graph theory, continuation to what we have discussed in the previous week. So first we have discussed about a relation between the various matrices, A matrix, B matrix, as well as Q matrix. So from the nodal analysis, we got A matrix, and then from the loop analysis, we got B matrix, cut set method, we got Q matrix. So A and B are orthogonal, B and Q are orthogonal. So these are the results that they have obtained, proof of which is not part of this course, so we will not get into that. So you assume that A and B are orthogonal, B and Q are orthogonal. Using this result, first result, A and B are orthogonal, we got the relation between B and A. Using the secondary relation, B and Q are orthogonal, we got the relation between Q as well as B matrix. Now using these two results, we have obtained the relation between Q and A. Then we have understood how to solve a given network using this graph theory. We have considered a kth element and a general or possibility of the kth element, and using that there are three ways. One way is to solve using B matrix. The other way is to solve using A and Q matrix. For B matrix, we need in terms of VE, then we have to multiply by B and we'll get the equation. For A matrix, you need to get in terms of IE and multiply by A to get the equation. For Q matrix, you need to get in terms of IE and then multiply by Q to get the equation. Then we have understood the concept by solving one problem using B matrix. So we have drawn the graph, simplified graph, then simplified directed graph. Then first we have obtained the B matrix. Then using that equation, we have first written all the matrices, and then we found the solution for IL. We have solved for IL. Then using the other equation of the mesh analysis, we got element currents, and then we have checked whether all these things are correct or wrong. Then we have started the circuit analysis with dependent sources, just a few examples and basic understanding of dependent sources. And in dependent sources, there is not much concept as such, but it is just how you solve the problem. So all the problems are simple, small KCL, KVL you have to apply, but you need to understand how to apply what difference these dependent sources make, because their voltage or current is dependent on other branches voltage and current. So you have to be careful with the polarity as well as the direction, polarity of the voltage and current direction. So if you solve directly, it is okay, there is no issue. But for Thevenin's theorem, there is one issue with the Thevenin impedance. For Thevenin voltage, it is straightforward. You have to just solve the circuit and accordingly you'll get Thevenin voltage. Whereas for Thevenin impedance, you have to short circuit the independent voltage source and open circuit the independent current source. But dependent voltage source and dependent current source will remain the same. So we have to consider a input voltage source and with supplying a current, and we need to get the ratio of that to get the Thevenin impedance. And we have solved this to get the Thevenin impedance. And then we have considered the simplified circuit, and then we have solved it to get the I2 current. Then we have considered one previous year assignment problem where they are asking the power supplied or consumed by the sources. So we have solved individually the voltages and currents for all the sources, and then we got the power. And for the notation, whether it is plus or minus, we have seen whether they're supplying the power or consuming the power, and we have checked in the question whether they're asking whether it is supplying or whether it is consuming. And similarly for resistor, it is straightforward, I square R summation, and we have done the same. Okay, if you have any questions further, then we can discuss, else we can end this session here. Do you have any doubts? Hello.
No, sir, no doubts. Thank you, sir.
Okay, thank you. And once again, happy Holi for all of you. Hope you have enjoyed today. No doubts. Okay. Okay, then all the best for your assignment. Do well in your assignment. This video will be uploaded by tomorrow. So if you have any doubts, you can go through the video, or you can mention in the comment section. And all the best for your assignment. See you in the next week with week 10. Good night.